Hello, this is Mark Summers from Summers Technical Services. We're going to go over the team project we've been working on last week and go over the SOLIDWORKS model that I provided. It's using the sheet metal module that some of you might not have learned in your ENGR 1304 class. So I'll go over some of the topics that'll be important to be able to modify your part model so you can get it to work for this project dimensions the team decides on. So the first thing I want to do is try to find my mouse here, and we'll open up the part model. So download it into your normal 3316 folder that you created already, and we're going to rename it. We're going to change the XX value into the team name. So all these are team projects, so all the files are going to be submitted as a team. So first thing I want to do is save as, and then change the XX where you normally put your student ID, type in your team name, whatever the team name is, save it as that, and that's how you'll submit it. So that's the first change you make. Second thing we need to do is define a material. So you'll right click on the model tree, edit material, and we've got some built-in library materials that, but we don't have the exact ones we're looking for based on the assignment. And so there's some steels, some aluminums, but it's not the right material properties because they're not in this common SOLIDWORKS library. So what you'll have to do is make a new library. And you can see I've already done that. I've got a new library called TSU, Texas State University. I've got a subfolder here called MFGE 3316. And you'll want to do the same thing and make these two new materials. So let me show you how to do that real quickly. So just on the tree over at the bottom of the open space down here, right click and say new library. And then you're going to type in the name of your library. Call it Texas State, whatever you want to call it. You might have other materials in other classes, so I might call it Texas State. And there's your new library. Once you get the new library, right click and say new category. And I'll make a category called MFGE 3316. And now I'm ready to create a new material inside this folder. Well, let's start with a default one, and then we'll modify the parameters. So just go into materials. If you're using carbon steel sheets or plates from McMaster-Carr, just pick one of these steels. If you're using the 5052 H32 aluminum, just pick one of these alloys over here. It doesn't really matter which one because we're going to modify the parameters anyway. So whichever one you're using, right-click on the one from the SOLIDWORKS library, right-click on it and copy, and then come down here to the new folder you just made, and then right-click paste. Right-click paste. So there it is right there. And the reason we have to do that is because these material library, you can't change these. These are locked here. So we got to be able to change these parameters. So once you make your material down here in your custom library, you can rename this thing, rename it to your material, whichever one it is, the aluminum spec or the steel spec. And now we can come here and change these parameters. So the parameters you're going to want to change are elastic modulus. And let's go ahead and, we're on English units, that's good. Elastic modulus, you're going to want to change the shear modulus. So put a number in for there, and pay attention to these units. Make sure you're using English units and that you're inputting the numbers matching these units. You're going to want to put in a mass density. You're going to want to put in a tensile strength, ultimate strength value there, and then a value for the yield strength. The other values in here are not going to play a role in our analysis. So you can leave those like they are. So once you do that, hit apply and then close, and that'll save that material down there, and it'll also save it. I'm not going to save it because I've already got mine. Save it in your library, and then it'll show up here on the material on this particular part model once you apply it and close it. So I'm going to apply either one of these to it, and so I'll apply this one. Apply, close. All right. So now there it is. All right, the next step is to go change the parameters of your part. We'll just go down in order. You're going to change your inside bend radius and your thickness and your K factor inside this sheet metal feature. So right click on sheet metal feature, edit feature, and you'll go in and change your inside bend radius, your material thickness, and your K factor to match the parameters that I assigned to you in the Canvas handouts I gave. Excuse me. So that takes care of that. The next thing is this base flange command. There's no changes to this. You need the 6-inch dimension across the top here, the 24-inch length here, so you'll make no changes to the base flange feature. The two edge flanges, we're going to change two parameters potentially on each one of these edge flanges. We're going to change the angle and the length. So if I right click on this, edit feature, you can change this angle. Say I want it to go from 30 to 60, and I want to change the length from 1 to 2. You can see it update down here, and when I approve that, don't change any of these other parameters because it'll change the model in ways you don't want it to change. So change those two parameters as you need. Hit the green checkbox, and so now it's got the different angle and the different length. And you can do the same thing on the other one. It's going to be symmetric, so you're going to want the same numbers on both edge flanges. So change that to the 60 like we did, or whatever angle you want to use for your assignment or your team project, and make them the same. So that'll take care of that parameter. All right, the last thing to do is to check to make sure that your flat pattern distance is correct. You're going to be calculating this using the equations I gave you in the handout. But just to double check that your calculations match what SOLIDWORKS is saying, SOLIDWORKS knows about the bend deductions and the K factors and all those equations that you've got in those handouts. And let's see if you want to see if it matches your calculations. You just right click, open up the flat pattern feature at the bottom, right click on that and say unsuppress. We're going to unsuppress it, and what it does is flattens out that flat pattern. Then you can just come here and grab this bottom edge, evaluate measure, on the evaluate tab measure, and it tells me the length there. And so that length cannot be over 12 inches. That's the maximum length you can have. And that number should match your hand calculations that you'll be turning in as well. So once you have that, you can right click on the flat pattern and then suppress it so it goes back to the bent shape of the assignment. When you are trying to pull your section properties and mass properties, I'll show you how to do that. So I want to do a cross section, say I want to look at it right through the center here. So maybe I'll grab my front plane and come up here to the section view. And that'll temporarily take a section of the part. It's not changing the part, it just lets you view it as a section view. And this makes it easy for me to grab this face here. So if I want to find out the area moments of inertia or the center of gravity, both of which you'll need to do, you can just go to evaluate section properties. Instead of a minute ago we used evaluate measure. Now we're using evaluate section properties. And you just grab that face and say recalculate. So this locates the centroid, the XYZ coordinates of the centroid of the shape, and the moment, area moment of inertia is this first number here. Is about the x-axis. We want the IXX value. SOLIDWORKS calls it LXX. I call it IXX in the hand calculation, but that's the value you want. And those are the two values you'll need, the center of gravity and the area moments of inertia. The last thing you'll need is, I'm going to go ahead and turn off this guy here. The last thing you can get is the mass properties, volume and the weight. And you can calculate those by calculating the area. We could have done that a minute ago. Let me grab that one more time here. Cut this thing again so I get a nice clean cut through the middle. If I go back up to section properties, I should have done this a minute ago. Calculate the area. you know the area of the cross section, you multiply by 24 inches, which is the length of the part, then you should get the volume. And so that volume is also showing up over here under mass properties. So if I go mass properties, recalculate, there's the density that was part of the material property. There's the mass of the part, and you can verify that that's correct based on your hand calculations. There's the volume. So the volume times the density should give us the weight. And so you can get those properties from SOLIDWORKS, and just as a good way to check your calculations you did. So maybe that's a good enough introduction to get you into this part model and make some changes. So if you have any questions, we can bring them up in class or stop by during office hours. Otherwise, stay tuned for the next video. Make sure you subscribe to the YouTube channel and turn on those notifications, because I'll be posting new videos next week to help you along in your team project. So until then, we'll see you next time.